Good morning, all, and welcome to the another session of Structural Analysis 1, Plane Frame Analysis. And as usual, could you please respond in the chat box that whether the slides are moving or not, so that I can understand that it's perfect. So anyone can respond in the chat box that slides are moving comfortably. So if you can do the needful. Yes, sir. Okay, I got the answers for thank you. All right, friends, today's would be the concluding session on the truss analysis. There are three methods that we should look into. One is, of course, the method of joint, which is a very successful method for analysis of the plane trusses. Sometimes for space truss, we also use this method of joints because these are the basic equations actually involved in analysis of the truss using the conditions of equilibrium. So when it's a question of conditions of equilibrium, I would say you can use some other conditions, including space conditions like sigma v, sigma h, sigma m, including in the x direction, y direction, and the normal direction. However, it's not right now in our scope of the learning, so we'll not go for it. Space structural analysis. So plane trusses are under our consideration, and we have successfully understood with enough practice and demonstration how to obtain the forces in the truss members using the method of joints. Similarly, method of sections is also a versatile method, especially when you are in interest of the calculating specific forces in the members which are dedicated or which are selective. In the last session, we have completed one demonstration also, and the counterpart of the another member today I'm going to demonstrate. But before we proceed any further, I advise all of you to fasten your seat belts with your writing tools, because today I'm going to give you a lot of work online, and which you need to help me in calculating the forces in the required members using both methods. As far as the third method is concerned, that is a graphical method, I will be supplying the study material, which is very interesting. However, it's not going to be the part of your examination, because the graphical method requires a lot of time, patience, and perfection in drawing the forces on the, let us say, on a graph scale. So graph papers and a lot of tools will be needed. In case of the ordinary solution, you just need to go for calculators and the vector forces or the vector operations ideally. But in case of the graphical methods, you need to subtend lot of you need to adjust lot of paperwork, and also if you are wrong in your scaling methods, it will not give you the perfect result. So looking into the complexity of the methodology, we will just go through the theoretical aspects of the graphical method. You just need to understand that there is some method which exists in case of the graphical method and what are their benefits, so that I will be supplying you the sufficient material for reading and references. However, those who are interested to go through it, they can go through it, but it's not compulsory for examination at all. So please take this in your account and study the method whenever you are free or when you are interested in, right? So it is our basic idea that we should be aware about the methods. However, the hands-on methods are the method of joints and method of sections. So earlier, let me take you to the next few revisions. Earlier we have completed the method of joints, and then we started with method of sections, where the complexity of the type of the trusses can easily be handled, and if the number of members are large in a given truss, you can definitely solve it easily with the help of method of sections. And that is what exactly you have experienced also earlier, and I'm sure that you are more than comfortable in determination of the member forces using this method. So here we started with this example, which we earlier have calculated with method of joints, and you have confirmed that the answers don't change even if you use method of joint or section. So these were the final answers, and we started with another little more detailed calculation on the member forces. For this problem, we started with the calculation of the reactions. We went for the selection of the members. If you recall, we are required to calculate member forces in member BG and GF. So BG we started, and BG we completed also, right here, and the same material is being circulated with you also, if I'm not wrong, and to your email ID, and you must have downloaded it also. So just go through it once, and now let's go with the another member solution. Now here we have reached to the another section, and now you know that when you are taking a new section in your given system, do not remember anything about earlier whatever you have done. That is what is the primary instruction given to all the students, that taking a section is completely a different thing when you change your section from one location to the another location. So every time it's a new numerical. In short, I would like to tell you that when you are selecting a section, first of all, second time, third time, fourth time, or n number of times, every time when you select a section, it will be a new numerical. So you don't need to remember that earlier, if you have taken already a section, like in this example, we already have one section that was crossing the members BC, BG, and HG. So we have already calculated some forces which were required. But now when you are again required to calculate member force in GF member, you can see here we have selected a new section with a red line, dotted line. And at this moment, I will not recall or even don't care that what we calculated in earlier section. So it's completely a fresh numerical for me now, right? So that you have to recall always, remember always, and that is the advantage. I would say that is a positive side of method of section, that you actually or practically don't need to remember earlier work. As in case of the method of joints, you have to keep track record of all the forces which were earlier calculated, including their sign and including their nature, like positive, negative, and you have to keep everything in your mind while you are running from one joint to another joint in the analysis. So in that case, on that point, your method of section doesn't occupy your memory more, right? But at the same time, it requires a lot of care in terms of developing the equations, as well as drafting the equations and solutions. That means sometimes your answer may come with a one click, or sometimes you require to go for equation and their eliminating methods and reducing the number of unknowns. So it requires a little care at that parameter. So each method has its own merits and demerits. So we have already inquired about method of joints, and we are on a second half of the method of section. So now I think you all are equally potentially known to or very well adjusted to this method. So let's all take a second section in this truss. So I request all of you to do the needful calculations, start working on your own pages and pens and calculators, and try to draw free body diagram, because we all know that within a one or two click, you will be in a position to get the value of force Fg. Our point of focus is force Fg because it is given in the question itself. That's why we are trying to calculate direct forces. So let me help you with the free body diagram. You all are requested and advised to draw the diagram in your notes. There is no hurry. Take your time. I'll give you 1 minute or 1.5 minutes to draw this force diagram by cutting the sections. Now, once you have cut the sections, I mean the members, convert them into the forces, as you already know, right? So here, every time we used to take left hand side and left hand side. So this time, let's take right hand side, right? Just for the sake of change. So I have shown all the forces on the right hand side section, and I'm going to consider equilibrium conditions for right hand side this time. So on my right hand side, when I cut members, I can see there are three forces. All forces are expected to work in tension. However, if the answer comes in negative, we'll see that they are in compression. So force DC, force DF, and force FG or GF, whatever you designate doesn't matter, right? So as I earlier have specified, that even if you change the designations from GF to FG, it doesn't change the value, neither it change the nature of the force. It's only the labeling, nothing else. So here we should not forget that we have two additional forces in terms of reaction at one end and 150 kilonewton applied external force in downward direction on the respective point D, if I'm not wrong, right? A, B, C, D, yes. Okay, so you draw this diagram in your notes and try to solve. You know what you need to do. You need to apply all the conditions simply one by one. In that process, do not forget to divide forces like FDC into components and FDF into components. So let me demonstrate it quickly for your reference. And so I was discussing that this is the force to be divided into components, right? And this FDF will also get divided in two components. Assume that it is a straight line, right? So we have two horizontal forces. You should take care that the angles of inclinations are not same, right? The angle of inclination for DF with horizontal axis we already have calculated. This theta will be considered, and for force FDC, these theta angle will be considered. So that to be taken care very well by all of us. This is around, if I'm not wrong, 30.82 and 30.39 or something. And the top angle was 20.8, right? So if you don't remember the values, just you can obtain it with the geometry. This angle can be obtained from 3 by 5, and this can be obtained by 2 by 5, right? So 10 2 by 5 and 10 3 by 5 will give you two angles values, and according to that, these are the components. This is a cos component, again this is a cos component. So in this entire system we have three horizontal forces, 1 2 and 3. So let me try changing the ink color for better this thing demonstration. Yes, so this is first horizontal force, this is second horizontal force, and this is third horizontal force. So in your equation for sigma h, there are two, or all the forces, surprisingly all the forces are negative. Don't forget that they are moving towards negative x direction. So all these 1 2 and 3 components will be negative in values. So sigma h will be written very comfortably. Now if we inspect again this horizontal side, we have I mean the right hand side, we have total 4 vertical forces. Like, which are them? Like, this is the reaction, this is the action, this will go negative, this is positive. Now this component of FDC sign will go upside, and this will go downside, FDF sine theta. And then finally, if if you see that sigma v and sigma h will not satisfy the the requirement, like in a one equation you have more than two unknowns, like more than one unknowns, then you cannot solve them. So keep them aside, and try getting the third condition into the picture. So that is sigma m equals to 0. And it will be wise decision that if you want to avoid unknowns in your equation, do not try taking the moments at other places like here and here. Take rather the moment here itself, so that these two forces will not be in your consideration. Even the vertical force will not be in the consideration. Only two forces you can see, one is reaction and this one. So that will be in your final equation, and surprisingly with a one click you'll get your desired value. However, it is good practice that even if you solve for these unknowns as well. So with this briefing, I give you 2 minutes and try figure out value of fg. I'll not show the solution right now, but I wish that you all try and calculate them. It's very easy. Take moment of these forces about point D. Let us say this is a point D. So take moment of fg and 237.5 about point D, and give me the answer for fg. So whoever is getting the answer, please raise your hand. I can unmute him or her, and we'll get the answer and then we'll check. So enjoy your calculations for next 2 minutes. I hope you remember the distances. This is, I would say it's a 5 meter. This distance is 5, and this height is 3 meters. Right. So now everything I have revealed, which just now you need to take care about things. Do not consider numerical sign while you are taking a moment. Always consider this is not in a consideration. Only consider clockwise and anti-clockwise moments, as you know already, right? So I'm waiting for your answer, and take your 2 minutes, 2.5 minute time. Give me the answer. Today you need to do a lot of work, and I'm at the ease. So I have all the answers. I'll be keep on asking you, and we'll be going for most of the individuals. Let me ask you personally that have you worked it or not. So first I will keep open it for everyone. Anyone can answer to this question, but then onwards I'll be little specific and directly going to the randomly selected student and ask for the solution. But for this time, you can raise your hand if you have answer of force FG. So take your own time, 2.5 minutes. I don't mind. I'm here only, not going anywhere. You should also be there. Don't go anywhere. By listening that today you have to answer questions, don't go anywhere. And please enter your details in the chat box. I can see 35 students have joined. So entries are less. Only 27 entries are reflected. So please enter your details in the chat box so that I can take your attendance from that. Very good. It is increasing. Don't forget to write your names and enrollments in the chat box. That is my primary source of attendance. Now you have been seasoned, like either you are in classroom or on the online classes. I'm sure that you are getting more than satisfied with your learning component, because personally I believe that whatever nice pictures or whatever good movie clips or whatever I use, that is on my side, that it is good for me. But I should understand that how much you are learning, that is more important for me. So that's why if you cooperate and if you support these efforts, like whenever I say you calculate something and answer to me. If you respond to that, it will be a complete learning for you as well as it will be a success for me also. So I hope you are going good and you are trying to calculate. It's a two-step calculation, boss. It's just a two-step calculation. Take moment of force Fg about point T and 237.5 kilonewton about point T and give me the answer. That's all. We all know the answer. The only thing is most of you don't reveal the or turn up with the uh, let us say mic. That's it. You just need to unmute your mic and say me the answer. That's all. So I'm waiting for a yellow sign of raise hand, and I'll be more than happy to unmute him or her for a response. So again, waiting 1-2 minutes. Always keep your writing tools with you when there is a numerical included in your any of the subject, and keep writing. Otherwise, your session will become little bit, you know, uh, not welcoming for online sessions. So waiting, and again waiting for answers. Somebody should answer. It's very, very easy. Any one of you can respond to it. So Vishwajit has come to the rescue. Yes, I have unmuted you.
Yes, sir. Good morning.
Good morning.
Yes, sir. The answer is 395.83.
Let me write somewhere 390.
5.83.
395.83. Okay. Whether it is compressive or tensile?
So tensile.
Okay, it is tensile according to you, right?
Yes, sir.
Okay, thank you, Vishwajit, for responding. And who one else would at least one more answer so that we can cross check, and then we'll go for the solution very quickly. So at least one answer, one more answer from any one of you. See, there are 35 students. At least one has to come up and bring the answer to the class. So it seems that only Vishwajit has done some calculations, rest are not attending with pen and paper. This is not fair. This is not fair. So I need at least one answer from one participant present over here. Raise your hand and give me the final words to change the slide at least. We have been stuck up with the slide since last 3 minutes. It's not a good practice. So quick answer from anyone? No one? All are not calculating? At least one answer. Very well. So let me, with a feel of dissatisfaction, let me change the slide, to be very frank with you. Right. Anyways, okay. So here is the secret unrevealed, and Vishwajit is correct that the force in FG member is 395.833 kilonewton, which is in tension. However, you can check here when I'll be sharing this with you, you'll be checking it that how to develop the equation, both sigma V and sigma H here. And finally, when they didn't work, you just need to obtain the third component of sigma m equals to 0. You can take moment about point D and it will give you the solution. But if you are interested in calculating FBC and FBF, you will not be get satisfied with this answer because you have many more to solve. So for that, we'll use this information here, Fg, somewhere in the missing component, like here, you can use it sigma h, and that's what exactly we have done here. You can see that it is negative, so we have indicated it with negative sign, and then further you can go ahead, you can calculate 150 plus 237.5 will give you 87.5, and then rest of the unknown forces can be very well obtained by using method of elimination of the equations, and that is how you will reach to the final answers here. So these answers, however, are not required in the question, but as a practice, it is always good to solve whatever unknowns are possible. So here you can see that the final answers are written very well. These two members are in compression and bottom member are in tension. So they are very well tuned with our understanding overall that the top members in a truss, normal truss, are normally in compression and the bottom members are usually in tension. The diagonals, of course, cannot be predicted without any calculation. So my ideal advice will be to all of you that always before predicting the nature in the diagonal members, have a hands-on calculation and then come to the conclusion. So with this, I think we all are, as you are also doing calculations, which I presume that you all are comfortable with both the methods now, method of joints and method of section. So of course, I have some extra information to share with you on the zero force member, and it will take next 5 minutes to explain you how the zero force member works, and then we'll go for practice, right? So get ready for the practice, and before that, let me give you that numerical. Okay, so we'll discuss on zero force members later, and just go through the example. Please draw this example in your notes, and let me know the forces in the members. Please draw this figure in your notes first. So all of us will draw this figure in the notes. You can see here it's a simple geometry truss and or a truss, and you can see the angles are specified. So therefore you don't need height of the truss. Ultimately, height is required to obtain the inclinations of the members, right? So that is not required at all here. 3 meter is a bay distance between two members together, and even your work has been simplified by, you can see that you have the symmetrical loading, so of course your reactions will be same. So you just need to work out the values of the member forces. Since I would mention one more thing here, in case suppose you are in an exam. For 1 minute you assume that you are in exam and the same question is there, for example. So if the instruction is using the method of joints, obtain the forces in the truss members, all members. So you can imagine that what amount of work you need to produce. But here is a key, here is a tip. You can see that these forces are symmetrically loaded. There is a symmetry in geometry also. So once you calculate any one side of the truss, let us say here there will be a sense of similarities, like force in AG will be same as in force in ED. Force in AB will be same as in case of force BC, right? Force in BF will be as equal and same as in case of force CF. And of course, the force in GB will be same as EC. The only unique force that will be in BC. So you need to work out force values in 1, 2, 3, 4, 5, and 6 members only. Don't go for this because they are going to be same. So you can simply, however, you can simply write a statement that due to the symmetry in geometry as well as in force. See, to say that you need to have symmetry in both, in the member, in the geometry, as well as in the load. Otherwise, you don't need, you should not go for that statement. So once you notice that my geometry is symmetrical, my loading is symmetrical, you can do half work, and then you can mention that due to the symmetry of geometry, the forces are same. So then you can tabulate all the forces. Let us say 6 plus 6, 12 forces. You can enlist in a table by simply repeating the force values, right? There is nothing wrong in that. However, be careful, as I said, when you want to say that, you have to be sure about the geometry as well as the loading condition. Then only you can say that statement. So I think I'm sure I'm clear on this, and now I'm sure that most of you have your writing tools available with you. Start analyzing the members using the method of joint first. So please calculate values of AG and AB. You have all the needed information here itself. Start with the analysis at point A, and you all have the reactions available to you, which you can refer and we can use it for the further analysis. So give me the answer of AG and AB that we will later on cross check. Once we do that, I will advise you to go to the joint G and B and find the rest of the forces. But first, as a principle, as we all know, that we should always start with less number of members joint. So joint A or joint B, it's up to your choice. But my advice is to start from here. So joint A, you can first analyze and give me the answer of AG and AB. So take your time and raise your hand once you are done with your solution. Right. You should ideally take not more than 3 minutes for this. And I would wish to listen the answer from the class itself, right? So it's 11:38, so we'll expect answer around 11:41. So till then, meanwhile, I'm here only, I'm not going anywhere. You also be there and give me the answer. It's a method of joint which is very simple in nature, sigma v, sigma h, right? As such, in this system, there is no horizontal force, so there is no horizontal reaction also. As you can notice here, only the vertical reactions are there. So I'm here only, and imagine that I'm roaming around in the class and you all of are calculating the numerical. The only difference is you cannot chat with your friends. Then that's the only difference. So take your time, 2 minutes to go. All necessary angles are specified. So divide the force AG into components because it is inclined force, sine and cos, sine 30, cos 30, and go for sigma V, sigma H, and obtain the values of AG and AB. So once you are ready, just let me know the answers so that we can proceed for the next slide. There are 5 to 6 students still have not joined because the class strength is much more larger than 35. However, I appreciate those who have joined the session. It's good, always good for you. At least some learning component will be there for everyone. And the best practice attending the online session is to keep your writing tools busy. Keep noting down important things as if you are going through an audio and video book, right? And important points to be uh, marked on the writing tools. The brighter side of this subject is that there are full of numericals, so which keeps you busy if you want to be, right? So again, let's come up with a hand raise, and I'm waiting for the answer. So once you are done, let me know. It's taking a little more time than expected. Yes, again, the okay, Vishwajit. Yes, Vishwajit, tell us. I have unmuted you.
Yes, sir. Force in AG is 8 kilonewton in compression,
8 kilonewton compression and
and force in AB is 6.93 kilonewton in tension.
very well, very good. So let's go ahead. Anyone else would like to share their answer? Thank you, Abhijit. I mean, Vishwajit, sorry. Uh, yes, anyone else would like to share the answer quickly? Anyone else? Any single voice? Change of voice is very much needed. I would appreciate if you come up with the answer. Let's tally the answers. Can it be right or wrong? At least you can tell me that you are doing something in your notes. So we should all appraise Vishwajit for doing this gesture, and he's calculating things parallel to us. It's a wonderful thing. I appreciate. And let me appreciate a couple of more of you also. Give me a chance and raise your hand. No one else. Sigma V, sigma H. That's all. That's what you need to come up with the solution. Okay, Lucy is there. Let me unmute. Yes, please.
Sir, I've also gotten the same answers. AG 8 kilonewtons compression and
Okay.
AB 6.93.
Thank you, Lucy, and thank you for your support and encouraging us with your answer. So let's see. Let's go ahead. It's a good combination of at least two students have answered it. So let's go ahead. Let me see. Oh, yes, they're right. Here you can see the solution. It's a ready-made solution, so it didn't take much time for me to put it over here. But the purpose of this is to give you the real-time experience, hands-on experience. That's why I have not typed it. I have just taken it from somewhere, and the same source of the data I'm going to share with you. It's a very wonderfully explained content I found, so that I'm going to share with you also the same one. But so the answers are right. Like AG is 8 kilonewton in compression, of course, and AB is naturally in tension. So that you can compare again going back. And AG is a rafter. It's called rafter. I don't know whether you are aware about that term or not, but it's called main rafter or strut, main strut, which is always in compression, and the bottom members are in ties, so they are in tension. So far we are right. Now please go ahead with joint B, right? At joint B and joint G, let's go to joint G. Come here, go to the joint G and quickly give me the other unknown answers, right? And try getting them. Unless you try, you'll never be able to come to know where are your errors or where you are making mistakes. So even if you don't want to share with me, that's fine. But at least in your own books, you should write something, try to solve something. Here we are talking about analyzing joint G, right? So let's go to the joint G and try to analyze for rest of the unknown forces like GF and GB. because these two are now well known. The only thing is you just need to obtain GF and GB. Once you do that, you can either go to point B. So that will solve your half of the truss, and then simply you can say that now you can replicate it because due to the symmetry, all the member forces will be same. So after analyzing joint G, you can come directly to joint B, and if you solve all the member forces attached to that, it will solve the purpose of entire analysis. So that's a good way of analyzing the symmetrical trusses. So method of joint in that way is very powerful, giving you the quick solutions, right? Because the only two conditions are required to be applied, sigma V and sigma H. There is no role of sigma M in method of joints largely. But in case of method of sections, you must refer to the third condition also. So at method G, this is the answer. I'll not reveal it right now. Let me wait for a few more minutes, and I wish that you raise your hand. So last time Vishwajit and Lucy responded to this question. Now I would appreciate, won't force, but appreciate if someone else answers. Otherwise, Vishwajit is already there. So we'll go to him and ask him the answer. Or Lucy, right? Okay. So someone else should jump into the calculation and come up with the answer. Let it be wrong, should not be a problem. I understand it's a little more equational work, so I'll give you 2 minutes more on this. I'll be waiting and you should respond. Okay, many people are writing in a chat box that same answer and all. I appreciate that, which indicates me that you are doing your parallel work. I appreciate, but what's wrong in raising a hand and answering to the entire class, right? So that is much more sophisticated way of answering the question. So if you come with answer, let me know. Don't go through these equations. There's no need to follow these equations. You stick to your own equations, right? These are in their own way written, and we have a practice of writing answers in equations in our own way. So everything is fine. You just need to focus on your equations. Try to get the answers for members, assuming at GF and GB. Now we are interested in GB and GF. We are focusing on joint G. Don't forget to take account of 3 kilonewton in this calculation. So 2 more minutes and then we'll carry on. I understand it's a little challenging for you because of the change in the angles. Here you can see this is the inclined component. So I completely agree that you require inclination of this component with horizontal axis, right? But will be the same angle probably. So you can use the equal angle 60 here. So this will be a 60 again. This is 30. Like that. Let me explain it for easy understanding. Let us say this is the line. This is also 60 and this is 30. So which makes this 90. Yes, we are perfect. We are right. So this will be 60 and this will be 30. Right? So should not be a problem now. You can divide this component in two components. Vertical goes like this. and horizontal. I decided not to give you any tip on this, but I could not stop myself because sitting like that on in front of a screen, it's little challenging. I understand. So now you have some forces, and yes, you also need to divide this force as well. Don't forget, right? So how many vertical forces we have in this? One, two, three, and four. This is known to us very well, so that you can use now. And how many horizontal forces we have? One, two, and three. Okay. So there are three horizontal and four vertical forces. Take care about the negative and positive side, and sine and cos of the 60 and 30. This angle, this will be 30, and the bottom angle for this member we can take as 60, of course. So with that, you can go ahead and try to solve the problem. If you wish, you can take 1 more minute, not an issue. 1 or 2 minutes. But this is how you learn, right? Or you should learn, actually. Because generally teacher thinks that if I have mentioned everything in an online session, it's very well taken up by each and every one students, right? Which is not true always. So we do understand that you require monitoring, you require support, you require help, but this is the best way to help you during the online sessions. That I ask you to do the work. If you don't come up with the right section, when I reveal the answer, you should cross check your answer. And if you are wrong somewhere, you can check your process or equations also. So I'm still waiting, and raise your hand with the answer. I hope most of us have finished entering the details in the chat box for attendance. Still, we have sufficient time where we can even go for one more section or method of section practice also. But anyways, at least those who have not responded, that's fine. But at least when this material comes to you, someone has made a chat here. Okay, that's regarding the entry of their numbers only. Okay, that's fine. That's good. So somebody should come with hand raise with the answer. Raise your hands, friends, for the answer of the member GFGB, and then we'll carry on with the calculation or the solution ideally. This was the last last calculation where we obtained this two answers. Now, one more answer is needed from your side, or should I straight away go to Vishwajit? Stop me doing it and somebody can answer. Yes. Okay. I think Vishwajit, I have unmuted you.
Yes, sir.
Yes.
The force in BG is 2.596 kilonewton in compression,
2.596 in compression,
and force in GF member is 6.501 kilonewton in compression.
6.501
01.
in compression.
Yes, sir.
All right, Vishwajit. Let's go to, thank you, and let's go to the next slide and is right. So it's worth appreciating that you are doing an excellent job. Even being on the online module, you have been consistent in your work. So that's a good way of learning. And I insist that everyone should do a parallel work. And this is how you obtain your final answers. Both are in compression because one is a rafter and second is the inclined, uh, I would say, diagonal member. And as I said, without calculating actual forces, don't predict that this diagonal will be in tension or compression, right? So friends, as we can see, the forces are determined, and you may have get the same answers here. Now let's check. uh, I think joint B is still pending. Yes. So again, when you go to the joint B, again you can find the pending member force, that is BC. So all the other forces are very well calculated, very well taken, and we all know that now the truss is symmetrical. So you can simply write down that truss is symmetrical about y-axis, and that's why all the member forces will be identical, including their nature, right? The only thing is you should not forget that bottom members should be in tension ideally. So here you can obtain the answer for the rest of the members, and that is how you can complete your numerical, right? So actually I wanted to share a couple of points regarding zero force member with you. Method of joint we have practiced, and you responded to the questions also. I appreciate that. And anyways, I'm going to, these are the theory points which are very easy and straightforward to understand. The crux of this zero force members concept is that if you have conditions like this, like here you can see there are some joints which are not other than joints from the support. So they are not support, but they are other joints like joint C and joint A. So whenever this things happens, and when you notice that there is no external force applied to this, I think the same numerical we have already solved. The only difference was this support was at this end. So now you very well know that the members, those are meeting at a point but don't have external force. And if you place them in the framework of sigma v sigma h, you will find that their member forces are zero. But there are necessary, they are required in the system for stability of the truss, right? Or additional support to the truss, existing truss. So here the same in case one, it is very simple. Now you know that. In case two, you can observe that even at this joint D, you will find that there are good chances of having zero force members over here. So in this process, you will find that you can definitely put the equations for any of the connected or selected joints, joint D, joint F, and you can put the equations in place. You don't need actually any of the information, neither in case of the distance or angles, or directly you can obtain that the basic sense of the equations can be determined, and it will reflect that which are the member forces should be in zero force, right? So naturally, let us say if I have forces here at point C and point D is to be inquired, there will be some force in DC and force DE. But naturally, the force in DF will be zero in that case. So here you can see that it's very well taken up. And this material I'm going to share with you, the original material from which I have taken these pieces of information, that I'm also going to share with you. And I'm sure that you'll enjoy that detail of the work. All the methods are discussed over there in a one set of information. That's why I liked it more. And if you don't get how to solve the trusses with the graphical methods, don't take pain for that at this moment. It's completely not a part of your exam. Just take it as the additional information which is required or which is known to you. If somebody asks you that, are you aware about the method of graphical solution of the truss, you should say yes, because I have gone through it, and you can read a couple of data information on that also, right? But in exam we cannot include it because it requires a lot of precision and time, right? So friends, with this I would say I will be giving you this data on zero force member, under what circumstances the zero force member takes place, that you can easily go through it. So thank you all for joining this session. I'm hopeful that method of section that we started with and method of joint that we ended with this session are very well known to you. Now you are, it's up to you, friends, that how much you practice, how nicely you practice on both the methods, method of joints and sections, and you should compare the answers also, right? So with this advice, and one more piece of advice, take good care of yourself, and take all the precautions in this existing COVID conditions. We should not be ignored anyways, and keep learning, keep practicing, keep doing numericals. At least you should do 2 numericals every day before you go to bed on a day, right? So I wish you all very best learning, and thank you all for joining this session. In our next session, we are going to begin with a new unit, that is the deflection of the determinate beams. Very, very interesting, and equally very, very important also. So let's be there. Let's meet up in the next session. Till then, take care. Thank you all.